So, Jose, what's our equation here?
F of x equals negative a, x plus 3 cubed, x minus 1, x minus 2.
Very good. Questions? I'll zoom that out for you so you can see it. All right. So looking at the next picture, give me a 0 and its multiplicity. Cameron?
Negative 2 and 3.
Very good. Again, because it kind of flattened out like that. Give me another 0, Jose, and its multiplicity.
1.
Multiplicity? Very good. Oh, Shelby, what's the degree? You just add the multiplicities.
Oh, yeah. 5.
5, yeah, very good. And that is quintic. And so, negative or positive leading coefficient, Justin?
Positive.
Positive. Positive leading coefficient because it points up on the left and down on the right.
Points down on the left.
I wrote that down backwards. Thank you so much. Appreciate that. Try that again. Points up on left, down on right. Okay, so Zella, give me an equation that would work here.
A and then x plus 2 cubed and then x minus 1 squared.
Very good.
How would it go?
I thought it was down.
Up, left, and down, right? When it's going down, left, up.
Did I say the same thing twice?
Yeah, I think it's.
Maybe I will. Okay, listen. I have these reversed.
Yeah,
I have both of them reversed. Oh. Yes. Thank you. And I'm really sorry if I confused you. I did not mean to. Negative leading coefficient points up on the left. I mean, we can look at it and see that's what it's doing. Sherry. And down on right. And then positive leading coefficient points, if I look over here, okay, down on left, up on right. Thank you. I have no excuse. None. Not even really tired, so whatever. Okay, sounds like y'all are getting it more than me, so good job. Okay, so we're now going to try this stuff with the table. So we've done it graphically, now we're going to do it numerically, which just means from a table. So using this table, it tells you in the directions that the zeros in the table are the only zeros. So here's a 0, here's a 0, that's it. And I know those are 0 because the y coordinate is 0. No zeros have a multiplicity greater than 2. So either the multiplicity is 1 or 2. Those are our only options. And then we're going to answer the questions that follow. A, identify the left and right behavior of f of x. So that means as x approaches negative infinity as it goes to the left, we got to figure out what f of x is doing. And as x approaches positive infinity going to the right, then we got to figure out what y or f of x is doing. So let's look at it. As I go this way, what's going on with f of x? It's going down because it's negative. So it's negative infinity. And on the other side, as x goes to the right, what's going on with f of x? It's going up. It's going positive. So what does this tell us about the degree? It's odd. Yeah. If they point in opposite directions, I know that the degree has to be an odd degree. I also know that the leading coefficient is positive or negative? Positive. Because over here, if it points up on the right, then it's positive. And on the right, it's going up. All right, so B, based on the end behavior, what must be true about the degree? Okay, so the degree we said was odd. And about the sign of the leading coefficient. So, and the leading coefficient is positive. And I guess we could say the degree is odd because they point in opposite directions. And the leading coefficient is positive because it points up on the right. Okay, so we already identified the zeros. The zeros are at x equals -3 and x equals 1. Now, how in the world can I tell from a table the multiplicities?
If the next number is like the same sign or a different sign.
Yeah, I look at the next numbers. I look at the numbers around it. So like for this one, I've changed signs. I've gone from negative to positive. So what's the multiplicity?
It's
1. Because that just means it goes through it. It went from down here to up here. So it just went through. And we said none of them had a multiplicity over 2. So I don't have to worry about it doing this number. And that was given in the directions. That's why that was given. So I know, So I know this has a multiplicity of 1. And justifying our answers, I'm just going to write sign change. Okay, what about x equals 1?
multiplicity of 2.
Yeah, must have a multiplicity of 2 because the sign didn't change. It went positive, hit 0, and then went back to positive. So it must be doing this number, which means that it has a multiplicity of 2. And that's because the sign doesn't change. They had both been negative, same thing would have been true. All right. Now I want you to look at this next one. You try this one. It's the same thing we just did. It's just in a different table.